Hello everyone. So today we'll be talking about chapter 7, which looks at physical and cognitive development in early childhood. Now, what exactly is early childhood? What years does early childhood span? Basically, when we say early childhood, we're talking about roughly the period from 2 to 7 years, right? And we're looking at how children's, physical development is, what is the trend of their physical development and what are some changes in terms of their cognitive development, right? So here we have this picture, which is, there are two different sets of pictures. So here, the first set of pictures is of Andy, and that looks at how he's developing physically, and the other is that of Amy. And we'll see how there are certain gender differences when we talk about development, right? So here what we see is that, here we see Andy at 3 years, right? Usually when children are, at 3 years, they are, more bow-legged, which is basically that, their legs have, a certain degree of, they're not extremely straight, the legs, right? That's why they're called bow-legged. Then you're seeing that gradually, and another thing is that, children are more pot-bellied, right? But eventually what happens is that children's legs and arms grow and they become much more adult-like, and they start to have flatter tummies. So for example, when you look at this picture, which shows Andy at 5.5 years, what you see is that Andy has, more adult-like proportions to his body. Because what we saw earlier as well was that when children are extremely young, one thing that is happening is, sorry for that spelling, right? One thing that's happening is that they have a much larger head than the rest of their body. But what is happening is that now what is happening between 3 to 7, sorry, it's not, yes. So what's happening in the years which are spanning from 3 to 7 is that your body is beginning to take more adulthood-like proportions, right? So your torso or your upper body is not bigger than your lower body, right? Or your head is no longer the heaviest part of your body. That's gradually changing. You're becoming less pot-bellied. Your tummy is getting flattered. If you had bowed legs, then those are becoming straight. Here, this is what you see. Then by 5.5 years, the bowed legs are gone. Again, you are beginning to be slimmer. So when you were younger, so if there was, you pot-bellied, which most children are, right? So now that is turning into a flatter stomach, and your bow legs are becoming straighter legs, are turning into straight legs. So overall what's happening is that children are beginning to take on more adult-like proportions. Their bodies are beginning to take on more adult-like proportions, right? And this is something that we can see through these pictures as well, right? Now when we talk about development overall, one of the things that we see is that there's this term which is called the general growth trend, or the general growth curve. And what this is basically that development is fastest, or it's steepest, when you are between 0 to, let's say, 3 years of age. So let's say this is the dotted line here, the red dotted line that is showing you the general growth curve, right? So development or growth is happening the fastest here, right? And then what happens is that it seems to taper off. So then growth seems to becomes slower, and that's why you see that this curve is not going up to the same extent, like it's not growing with the same sort of gradient, with the same sort of ratio. So this basically means that the growth has slowed down. And then in adolescence again, you see that, there's again a rapid period of growth, right? So the general growth curve, that's what it posits, that, from there is rapid growth in infancy, right? So there is rapid growth in infancy. Then what you see is that growth slows down in early and mid childhood, right? And then what you see is that the growth speeds up again during adolescence. Right? But there will be certain exceptions to that. Now let's see. So for example, one of the things that we see here is lymph tissue, which is denoted by this yellow line here, right? What we see of lymph tissue is that it's growing very fast, right, during the early years, and then it reaches a peak here, right, which is around 11 years, and then it seems to decline. Now, what is lymph tissue responsible for? It's basically responsible, or it contributes to your body's immune system, right? So this is basically when you have more lymph tissue during the growing years, this is basically your body's protective measure, which is protecting you from all sorts of diseases, from all sorts of infections during childhood, right? And then when you reach adolescence, lymph tissue starts to decline, right? And then you might become more susceptible to contracting various kinds of diseases, right? When you look at brain and head, which is given by this blue line here, right, what you see is again, sort of trend that we observe with the general growth curve, that development is extremely steep, but it's steep till around 5 years, right? And then what happens is that it becomes much more gradual as you hit like around 10 years or even before that, right? With the genitals, which is given by this green line here, again, genital growth is slow. It's overall slow during early childhood, middle childhood, and then suddenly it rises very sharply with the onset of adolescence, right? So so this is a little bit about the general growth curve and how different body functions. So for example, lymph tissue, the brain and the head, and the genitals are growing from birth till here we have till 20 years of age, so around early adulthood, right? Now next we look at these two other major areas of physical development. During early childhood, and we look at skeletal growth, right, and we look at brain development. So again, two very, very important areas of development. Now when we look at skeletal growth, right, we've talked about this earlier as well, that age of a child, right, or their physical maturity is best measured by looking at how much it's looking at their skeletal age. And what does skeletal age really tell us? Skeletal age tells us how much of, because when children are born, they are born with soft cartilage instead of bones. There are bones there obviously, but they're softer, right? So how much the soft cartilage, what percentage of the soft cartilage has matured into bone, right? This is one of the things that we see when we're looking at physical development, right? So one of the things that you see is that during early childhood, when you do x-rays of children, what you see is that for children who are between 2 to 6 years, right? Between these years, what you see is that 45 new epiphyses, sorry for the spelling there, new epiphyses have emerged. What exactly are epiphyses? So they're basically centers at which the soft cartilage is turning into bone, right? Or is hardening, right? So when you see that, what you are looking at is that there is significant development in terms of skeletal growth, right? When we come to talking about brain development, right? So we're looking at different aspects of it. One of those is that, when we consider brain development, one of the things that's happening is that, there's not just one thing happening, right? There are different aspects of development coming together which are making certain skills possible. So for example, when you look at this age range, which is again, you're looking at children starting from 2 years of age to around 7 years of age, right? You see that they're mastering a number of different skills, right? So, going from 2 years of age, they start learning to walk at 1, right? And then they were mastering that, right? But during this age range, they have not just learned to run, right? They've learned to skip, they've learned to jump with, a lot more precision, right? They can throw a ball much more efficiently in a particular direction. They can kick with a lot more force, right? So they can balance much better. So for example, if you're playing a game of hopscotch, right, they're able to balance a lot better. So they're basically mastering a great, number of skills. And that is happening because of certain things that are occurring at the level of cells when we talk about brain development, right? Now, what all of these processes are involved? One of those processes are something that we term myelination, right? Now, what exactly is this? We've talked about this earlier as well. This process involves coating of the axons that basically send out signals from neurons, and what this does is that it makes the neural impulse much more efficient, and it makes it much more faster, right? Then you have all of these other processes that we've touched on earlier as well. Another one is what we term synaptic pruning, right? Which is basically, again, that a lot of your synapses are dying. Those that were not used, they eventually die. And this again, when you do not have an access of synapses in your system, then the ones that are existing, that are being used, are becoming more efficient, right? Then you also have the development of synapses. Again, this is basically that neurons are forming connections with one another, and because of that, certain skills or your ability to carry out those certain skills is becoming more efficient, right? What else is happening? Then there's also something that we call cell death, right? Again, those connections in the brain that are not being used, or those cells that are not being they're not being activated, are dying, and that is making the system more efficient as a whole. And that is basically enabling all of these different systems that we see here in terms of physical development. But that's not all. We are also seeing with all of these processes happening, we're also seeing changes in how well children are able to sustain attention. How well are they able to sort of acquire and use language? Because another thing that we ought to remember here is that children are making huge gains in language. That's something we'll talk about later in the chapter as well. So, sustain attention, you have language, then you also have development in memory, right? You also have, some sort of development in perception, right? Imagination. So all of these functions, physical, these are, you have the physical functions here, and you have the cognitive ones here, right, are sort of becoming more efficient, and they're developing because of these different changes that are occurring in the brain, right? What are some of those changes? So one of the things that you see is that when you consider brain structures, so when you do fMRIs or CT scans of children who are in this age range, one of the things that you see is that there is an increased level of activity in their cerebral cortex and in the frontal lobe of the cerebral cortex. Now, basically, what is the frontal lobe responsible for? The frontal lobe basically is responsible for, planning, right? It's sometimes called the executive center of the brain, in the sense that it's sort of deciding what to do and when to do it, right? So one of the major milestones of early childhood is inhibiting impulses, right? And inhibiting impulses in order to exhibit more planned action. Right? So that is one of the major milestones. What does this exactly mean, that you're inhibiting impulses in favor of more planned action? So basically, for example, a child might be trying to, for example, throw a ball into a particular box, right? And they might have an impulse to throw it with a particular amount of force. But when they observe that, when they hit it with this amount of force, it does not meet the goal, which is that, you want the ball to land in the box, right? What you have to do then is that you have to plan a certain action, right? You have to plan with what force you'll be throwing that ball. You have to plan in what direction you'll be throwing that ball, right? So, middle childhood, because earlier what you see is that mostly children are driven by impulses, right? But middle childhood is about inhibiting impulses and, favoring planned action. Children are learning this at this age. And in keeping with this, what we see is that the frontal lobe of the cerebral cortex shows much more activity than it does at other ages, right? Then there are other parts of the brain as well. So, for example, another area which is called the cerebellum is also developing. Now, what is the cerebellum responsible for? The cerebellum, again, is responsible for balance and equilibrium. So what we discussed earlier, that how children are able to play hopscotch or run around without falling as often as they were doing when they were younger, right? So that has something to do with how their cerebellum is developing during this age. Another thing that's happening is that connections between the cerebral cortex and the cerebellum are becoming much more fine-tuned, and that is again contributing to better balance and equilibrium. It is contributing to a host of different abilities. What you see is that children who have some sort of damage to the cerebellum, they suffer from a lot of different problems related to thinking. So overall, what the cerebellum is contributing to is something that we call motor coordination, right? Which is involved in all of the tasks that we've talked about earlier, like being able to jump, hop, throw a ball in a particular direction. It's also related to a skill that children most often learn during this stage, which is printing or writing, even drawing, right? So this is about the cerebellum. When we talk about the cerebral cortex, another thing that's happening with the cerebral cortex is that children have begun to show, when we talk about the cerebral cortex, so one of the things is that there's increased activity in the frontal lobe. Another thing is that there is increased activity in the left hemisphere. Now, I'm hoping that most of you know that the cerebrum has two major hemispheres. One is the right hemisphere and one is the left hemisphere. One of the things that you see is that between the years which are around 2 to 7, right, there is a rapid growth in the left hemisphere. Now that again parallels what is going on when we look at development that's occurring during this stage, right? What is happening is that there is a rapid increase in children's language usage and their language learning, right? Now, language is believed to be housed in the left hemisphere, right? And one of the things that we see is that, and that again, shows how at this stage your brain is beginning to lateralize, right? What does that mean? That basically means that the brain is specializing in terms of what hemisphere of the brain does what, right? So most often for most people who are, and this is something that is tied in with handedness, right? What exactly is handedness? So handedness is, when you show a preference for using your right or left hand, right? Now, most people show a preference for using their right hand, right? Most babies also orient towards their left side, which basically frees up, their right side to be more active. And most people are right-handed, right? They show a preference for using their right hand. This basically does contribute to determining which is the more dominant hemisphere in your brain, right? So this is something interesting, that for people who are left-handed, right, so their language center is not primarily the left hemisphere, rather it's a combination of both. Either it's the right hemisphere or it's a combination of both, right? So one of the things that you see is that people who are left-handed seem to have less lateralization of the brain, so less specialization of the brain. For people who are right-handed, there is more lateralization of the brain, right? And you have the left hemisphere as the more dominant hemisphere and as the hemisphere that houses language, right? Additionally, what you see is that for people who do have the left hemisphere as the more dominant hemisphere, right, so growth in the left hemisphere is much more rapid during this stage, and the right hemisphere seems to grow much more gradually during this stage, right? Whereas for the left hemisphere, growth is much more rapid during this period, and then it might slow down, right? Now moving on to, other areas of the brain. So another area of the brain which is related to our discussion of the right and the left hemisphere is the corpus callosum. Now, what exactly is the corpus callosum? So the corpus callosum is a nerve of fibers that connects the right and the left hemisphere. And for any task, be it related to language or spatial distance, right, what you do need is for the hemispheres to work together, and to exchange information, right? So as the corpus callosum is developing, right, the connections between the right and the left hemisphere are becoming much more efficient, and that is leading to more efficient thinking in all sorts of areas, right? That's one thing that's developing. Then you have another area of the brain which is called the reticular formation. Now, what exactly is the reticular formation? Again, the reticular formation is a structure in the brainstem that controls alertness and consciousness. As this is becoming more mature, children are becoming more capable of sustained attention, right? So here we are able to see the corpus callosum. This is the corpus callosum, which is, the connection between the right and the left hemisphere. Here at the rear of the brainstem, you have the cerebellum, which is responsible for motor coordination, right? Then you have the reticular formation here, which is, again, responsible for alertness and consciousness. Moving on, you have the pituitary gland here, which releases, now when we talk about physical development, two kinds of hormones which are essential for growth. One of them is called the growth hormone, right? And the other is called the thyroid stimulating hormone, or the TSH. Now again, the growth hormone generally, right, basically what happens is that children inherit certain genetic material, right, and those genes then determine how these hormones are released, right? So the growth hormone stimulates growth in a variety of different areas. So the growth hormone, what it does is that it exercises impact on all body tissue and sort of determines, for example, what height you will grow to, right? So if you're deficient on growth hormone, you will only grow to a mature height of, let's say, something like 4 feet and a certain amount of inches. So basically, growth hormone determines the growth of all kinds of body tissue except for the central nervous system and the genitals, right? Whereas what the TSH does is that it stimulates a gland which is called the thyroid gland, which is located near your neck, right, to release thyroxine, which is a hormone, right? And thyroxine, what it does is that it makes one of the things that it does is that it makes the growth hormone and its absorption much more efficient. Another thing that it does is that it's essential for brain development, and if a child is deficient on thyroxine, right, there are chances that they would be mentally retarded, right? So these are two hormones, the growth hormone and the TSH, which are essential for healthy development. Now, we were considering how hormones can impact something like development, but there's another factor that seems to have an impact on development, and that is, how emotionally nurturing or deprived your emotional environment is. And one of the things that emotional deprivation can lead to, and this is something I think we've talked about earlier as well, is psychosocial dwarfism. Now, what exactly is psychosocial dwarfism? Psychosocial dwarfism is a condition which is marked by decreased levels of, even G8 secretions, growth hormone secretions. Again, you have, short stature, right? And one thing that you have, which is unique to psychosocial dwarfism, is that you have a lot of problems in adjustment. And this is what sort of sets apart psychosocial dwarfism from any other physical sort of condition, which might be related to shorter stature and decreased G8 secretions, right? So, something like emotional deprivation can contribute to a child not being able to grow normally, right? So I think we're moving towards the end of the video.